Okay, hi guys. So in this lecture, we'll be continuing on seeing some more examples of SN2 reactions, and before that, we'll be taking on the compounds which will not show SN2 reactions. So just write down that following compounds will not show SN2 reactions. Okay, so the first one in the list is we have chlorobenzene, or simply this. So why will this compound not show SN2 reactions? Because this single bond is actually having double bond character because of d orbital resonance. Chlorine has a uh, unfilled d orbital, so the resonating uh, pi electrons in the benzene ring can actually go to Cl as well. Okay, so because of which the single bond character get weakens and it acquires pi bond characters. Hence, it would be difficult for the reagent to actually attack the double bond. Okay, the second one is we have something like this. Okay, so this is called vinyl chloride. So again, one reason is d orbital resonance, and the third example is we have something like this, a bicyclo compound with a Br as at the bridgehead carbon. So when actually OH minus some or something like that attacks on the bridgehead carbon, so bridgehead carbon in the intermediate state gets a sp2 character, which violates Brett's rule, which says that the bridgehead carbon in bicyclo ring which is having less than 8 carbon members cannot be sp2. Okay, so let us look at the fourth example, wherein we have CH3, CH3, CH3 and CH2Cl, and when it actually reacts with OH, what will happen is the OH will try to attack it from backside. Okay, backside. So what will happen is there is a lot of steric hindrance already available in the compound, so due to steric hindrance, this reaction will not go in forward direction. Okay, so now these were the examples wherein we looked at what compounds will not undergo SN2 reaction of alkyl halide. Now we will be looking at the compounds which will be formed out of this substrate when we are reacting this with these reagents. We have aqueous KOH. So what would be the product formed? It would be simply SN2 product with KBr as the side product. What happens when we are reacting with KSH? Again, we have CH3SH plus Br minus, or we can write it KBr. Okay, what will happen when we react it with ETO minus? So it will have CH3OET, ether will be formed and Br minus will be relieved. We have something like this and Na plus. So what would be the product? Product would be simply CH3 CO2 and CH3. Okay, so this is a ester formation, and plus obviously NaBr you can write. And for this one we have NaN3. So for this we would have NaN3 plus NaBr would be formed. Okay, so these were the products that were formed. Now let's look at some specific examples wherein we have something like this. We have CH2Cl here and a Br here. So what happens when you actually react with NaCN? Now the Cn will act as a nucleophile here. Will it replace Br or will it replace Cl attached on this carbon? Obviously it will replace this, because in the intermediate state, positive or carbocation formation or sp2 or not sp2, the positive charge, a slight positive charge comes in the intermediate state, and if that positive charge comes on this phenyl ring, it will lead to a formation of aryl carbocation, and aryl carbocation is highly unstable, so we should avoid using it, because in the example we already have chlorine attached on a primary carbon, so we can directly leverage that, and plus NaCl is useless. Okay, we have another example. We have Cl, CH, so which we react with KSH, so which carbon it will attack, this one or this one? Again it will attack this one. Why? Because if it attacks on this one, we will have something like vinyl carbocation forming in the intermediate, which is highly unstable. Hence this carbon would be chosen up by SH group, and you can form the remaining useless compound formed after the reaction. Okay, so we would have something like this, wherein we have double bond I on double bond, and Br on a secondary carbon. So we reacted in aqueous KOH. Again, what will happen is this carbon would be attacked by OH, and we would have something like this compound. Let's take another look. We would have similarly, if we have some this and this, we attack again with NaSH. So this NaSH will attack on this carbon atom. I hope by now you have a clear understanding why will attack on this carbon atom. I need not repeat it. Now let us look at this example, wherein we have Cl coming out of the plane, and this is actually going to attack. So this is also called an acetate ion, for just your information. So this O- will attack this backward, so it will form a wedge, a dash positioned at this carbon atom, because it will attack behind the plane, because Cl is also already present above the plane. Okay, let us look at the product of this reaction. We have this plus this and CS3 here. So what would be the compound from this? So obviously this CS3O- will attack on CS3 to form ether, and later, as we have discussed, that this group is a very good leaving agent. Okay, so this would be quitting as this is extremely good quitter. Okay, let us look at another examples, some more examples, wherein we have, let's suppose, ROH with let it react with Na only. So we would have something like A compound, and from A compound we react with OTS to have B compound, and from A only we reacted with TSCl to have C compound. You have to identify A, B and C. So the A compound in this case should be RO minus Na plus. B compound here must be CS3OR, and OTS minus will be relieved, so CS3OR, I will write CS3OR, and C compound here would be ROTS. Okay, this will actually attack on TS to relieve chloride. Okay, so now two important cases we actually already discussed in some previous lectures, in which supposedly we have, in case of suppose we have CS3Br here and it is getting attacked with KCN. So what would the product form? We have already discussed in our first lecture of alkyl halide chapter. So this product would be formed. Why? Because K plus and Cn minus, so negative charge is on C, so this C will actually attack on this carbon atom. But in the other case, on the other hand, if we have CS3 and we are here, and we have something like AgCN here, so in this case this is actually a covalent bond, unlike the previous one wherein it was a ionic bond. So in this case N will be attacking as the negative charged atom, so N will be actually attacking on this CS3 to give rise to isonitrile. Okay, so Please remember these two reactions. They are very important and they are frequently been asked in JEE level competitive examinations. Okay, so the reason is, let me write down the reasons. First is AgCN is covalent. This implies nitrogen atom will attack as a nucleophile, and in the second case, uh, uh, KCN is more ionic. KCN is ionic, hence C will attack as a nucleophile. Okay, so this brings us to the end of this lecture. In the next lecture, we'll be seeing more of such examples in which we'll be also seeing Finkelstein reaction and Williamson ether synthesis. So till then, good luck and goodbye. Keep revising all your important organic lectures to have a good grip on the concepts.